Alright, part B. Find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. So, how do we find a maximum? Find the derivative, figure out when it's 0, so find our critical values. And since we're doing this on an interval, we want an absolute maximum. We can check the endpoints and our critical values. So let's take a look at part B. We need to look at the derivative of r of t. Now, this is one we could do by hand. It's not a very difficult question, right? Not a difficult function. So if we took the derivative of our function, we get 2,760t minus 2,025 times t squared. We want to know when it's equal to 0. We can factor a t out. So we get 2,760 minus 2,025t. And that gives us t equals 0, and t equals 2,760 divided by 2,025. So if we calculate that, we should get about 1.363. Now, this is a calculator part of the test, though. We don't have to necessarily do it by hand like that. What we can do is use our calculator to our advantage. In this one, like I said, we don't necessarily have to do this. Pretty simple one we can do by hand, but there are a lot of problems on the calculator part of the free response where we do need to do this. So that's why I'm going to go through the process with you. We want to look at the derivative of this. You might get a function that's really ugly and nasty with e and trig and all sorts of crazy stuff that you won't be able to do easily. Well, what we can do is have our calculator do it for us. In y sub 2, I'm going to come up with the derivative of this without actually figuring out the derivative of that on my own. We can do math 8. We're doing the derivative in terms of x of y sub 1 in terms of x. Alright, so I went over this with our calculator techniques, like review on our first AP review. There are videos you guys can watch and you should watch. This is something you need to know how to do. There are certain problems where you have to do it. Well, I'm only going to look at the graph of the derivative. I don't care about the original one, so I'm going to go up to the equal sign, hit enter so that it's no longer going to be graphed. In our window, we want to go from 0 to 2. Right, because that's our window for the problem, our interval. So if I graph this, you can see part of the graph there. And it's working. Still graphing. There we go. And then we see the graph come down through here. We can figure out that 0 using second trace, option number 2. We want a left bound. Well, 1 is to the left of that, so I'm going to just type in 1. Right bound, 2 is to the right of our intersection, or our 0, and then hit enter one more time. And there's the same answer we get by solving it by hand, 1.363. So another thing that I showed in the calculator techniques, we can store this number just in case we need to use it for other things. If you go to second quit, so you get out of that graph and hit the store button, we can store that for, let's just do it for A. Alpha A. So now if I use A, it's going to use that whole value, 1.3629, so on. Right? But to figure this out, now what we need to do to find the absolute max, we're going to compare the endpoints, so R of 0 and R of 2, to our critical value, R of 1.363. And again, we can use our calculator to our advantage for this. I'm going to do vars, y sub 1, and I'm going to have the calculator put 0 into that function. Make it 0 out. If I hit second enter, oops, whoa, calculator's going crazy. Hit second enter, I can go back and edit this and put in A. Right? I stored that whole number in there. I can put that in for A. We get 854.527. And then second enter, I gotta go back in and put 2 in. And we get 120. So we had 0, 854.527, and 120. So our maximum occurs at t equals 1.363 hours.